Hello students, my name is Dr. Salahuddin, working as Associate Professor in Noida Institute of Engineering and Technology, Pharmacy Institute, Greater Noida. Today I will discuss about the narcotic analgesics, and this topic I have divided into the two part. The first part I will discuss in this lecture, and the second part that I will discuss in the next lecture. So, start from this narcotic analgesic. So, first before starting this narcotic analgesic, we have to understand about the what is analgesic. Analgesics are the drugs that relieve pain without significantly altering the consciousness, means without the loss of consciousness, the drug that causes relief from the pain, that is called analgesics. Now, the next term is narcotic analgesics. They are also used for treat the pain, that is acute dental pain, and especially in patient who cannot tolerate the non-steroidal anti-inflammatory drugs. So, here the non-steroidal anti-inflammatory drugs that are also used as analgesics, but they are not under the category that is narcotic analgesics. So, there are two categories, that is the NSAID, the separate categories for analgesics, and here I will discuss about the narcotic analgesics, the different categories of the analgesics as the narcotic agents. So, here what are the main approaches for the management of pain? So, there are three types of pain: mild pain, moderate pain and the severe pain. In the mild pain, what we have to do? At the step 1, non-steroidal anti-inflammatory drugs, that is the aspirin, acetaminophen, or some analgesic adjuvant that we can use. If the pain is persisting or the pain also increasing, that is there is no relief by using these non-steroidal anti-inflammatory drugs, that in the step 2 what we can do, we have to use the less potent opioid, that is the hydrocodone, codeine and the tramadol, plus non-opioids. Non-opioids means NSAIDs, acetaminophen or some analgesic adjuvants. Again, if the pain persists or the increasing the pain, then the step 3 we have to use the potent opioids, that is the morphine. The potent opioid also includes this oxycodone. So, morphine, codeine, hydrocodone, these are the opioid analgesic, and it comes under the category of narcotic analgesics. So, in the broad term, the analgesics that we can divide into two parts, that is opioid analgesics. The another name of opioid analgesics is narcotic analgesic, and the non-opioids, that is non-steroidal anti-inflammatory drugs. Narcotic analgesics are the potent analgesics and which are effective for the relief of the for the severe pain, and These are the selective central nervous system depressant, means they are lipophilic, they are crossing the blood brain barrier, the log P is high and the administration produces, it causes tolerance, dependence, addiction, and the narcotic analgesics classified according to the site of action, it includes centrally acting and they can further divided into the narcotic and the non-narcotic. So, these are the centrally acting, some are peripherally acting. Peripherally acting analgesics, NSAIDs, they are peripherally acting, they are not centrally acting. So, it includes non-steroidal anti-inflammatory drugs, it includes analgesics and antipyretic. The narcotic analgesics are the analgesic which causes sleep or loss of consciousness with analgesia. So, as I have already told you that the opioid analgesics and the non-opioid analgesics, what is the basic difference between the opioid analgesics and the non-opioid analgesics? So, here the opioid analgesics, the opioid, simply we can say opiates, they have physical dependence, addiction and the tolerance is developed by using opiates. They have potential for abuse and then the opiates act mainly through the central nervous system, whereas the primary analgesic action of the non-opiates is peripheral. So, that is why we are calling it as a peripherally acting drugs, that is the non-steroidal anti-inflammatory or we can say the non-opiates. They are more powerful analgesic agents and do not reduce the inflammations. As NSAID, they are used as in pain and inflammation, but this narcotic analgesics basically they are used as only analgesics. They undergo a specific first pass metabolism and the preferred route for the administration is parenteral. Now, come to the opioid receptor, how those opioids like is the narcotic analgesics act by which receptors. So, this opioid receptors, these are distributed in widely in the brain. The second is the spinal cord on the peripheral neurons and the digestive tract. So, this opioid analgesics produces the analgesic effect through the interaction with the specific receptor that is called that is called the multiple opioid receptor. And this multiple opioid receptor, these are classified by Martin and co-workers in 1976 and these receptors include the mu, kappa and delta. So, these are the three important receptors are used as opioid analgesics. So, what are the location of this these receptors, either the mu receptors, delta receptors and the kappa receptors. Mainly the mu receptors are present in the mesenteric plexus, brain and spinal cord, submucosal plexus. Delta receptors, it is presented in the brain and mesenteric plexus, not in a spinal cord, and kappa receptors present in the brain, mesenteric plexus and the spinal cords. So, these are the some location of the receptors like mu receptors, delta receptors and the kappa receptors. and if these if the agents binds with this mu receptors, that it will performs some specific functions. So, the clinical effects of this mu receptor is analgesia, changes smooth muscle tone, that also sedation, mood alteration, nausea, vomiting. This decreases delta receptors, decreases colonic colonic transit time, kappa receptors, central analgesia, decrease colonic transit time, and visceral nociception antagonist. So, these are the these are the location of the mu, delta and kappa, and some clinical effects of these receptors. Now, the classification, come to the chemistry part of this opioid analgesics. So, opioid analgesics, first morphine and related analog, second is morphine, the third is 6,7 benzomorphan, fourth one is 4-phenyl piperidines. So, first thing we have to understood that what is morphine. So, in the morphine we have basically 5 ring, we have 5 ring. This is the structure of morphine. So, in the structure of morphine, basically it is A, B, this is C and D and E. This is 5 ring, A, B, C, D and E. This is the as simple structures like this one, morphine. I have redrawn structures. Now, the numbering, it includes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 17. So, these are the numbering of the system involved in the morphine. So, in the morphine, the another class of this morphine analog is the morphine. So, what is the basic difference between this morphine and the morphine? Here there is a one there is a one ring present here in the morphine, and that particular ring also present in the morphine. And come to this ring, at the ring C, here there is a one double bond present in between 7 and 8 position. So, here there is a no double bond between 7 and 8 position, and the no ether linkage in between 4 and 5. So, this is morphine. Now, come to the benzomorphan. Benzomorphan is also a derivative of this morphine, morphine related analog. And next is 4-phenyl, 1, 2, 3, 4, 4-phenyl piperidine. So, I will discuss one by one in the separate slides. So, here first I will discuss about morphine. So, in the morphine is that opium, morphine is obtained from the opium. It is less effective analgesic than pure morphine. Morphine is isolated from the opium. If you are using as a pure opium, then it is less effective analgesic than the pure morphine, because it is slowly absorbed, and it has been historically used for its constipating action. Morphine itself, which was discovered in 1809, a variety of effects, among which are increase in the tolerance to the pain, somnolence, euphoria and antitussive effects, respiratory depression, constipation and emesis. So, apart from these action of this morphine, in addition it has high addiction liability of the morphine. So, that is why with this morphine comes under the category of narcotics. So, derivative of morphine that we can also used as a narcotic analgesics. There are several derivatives of morphine that basically we are using as narcotic analgesics, and we have some improved bioavailability and improved side effects. Now, here next, this is the general structure of morphine. So, morphine we have the 3 substitution. So, at first substitution 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, we can substitute at now 14, 15, 16. So, here are third substitution at third position substitution at the 6th position and the substitution at this nitrogen atom. So, there are 3 substitution R, R prime and R double prime. So, in the morphine R equals to H, R prime equals to H, but R double prime equals to CH3. Codeine CH3, hydrogen and CH3. Interesting example of the derivative of this morphine is heroin. Here the R is substituted with acetyl group, again R prime is substituted with acetyl group. So, it is a diacetyl morphine. We can name as this heroin as a diacetyl morphine. So, next is nalorphine. Here R is H, R prime is H, R double prime is CH2, CH double bond CH2. Next is hydrocodine. R equals to hydrocodine, R equals to CH3, R prime equals to H and R double prime is CH3. So, that we have some compounds derived from the morphine is codeine, heroin, nalorphine and hydrocodine. Now, come to the very important part, that is the structure activity relationship of morphine. So, as in the structure of morphine we have 5 rings, 5 rings with some important characteristics. So, there is one hydroxyl group and this hydroxyl group we can call is the phenolic hydroxyl group. There is a 3 double bond present in it, phenolic hydroxyl group. There is a one OH group also present at ring C and this one is alcoholic hydroxyl group. So, both the both the hydroxyl group have different properties. First is phenolic hydroxyl group and the next one is alcoholic hydroxyl group, and there is a one double bond. So, we can do the modification, at this point, we can do the modification at this point. We have already seen the structures derived from the morphine. So, we can do the substitution, that is the modification of 3 and 6 hydroxyl group either by CH3, either by acetyl, either by hydrogen, and it that the different types of compounds that we can derive. Second one is we have the double bond system in between 7 and 8, that is the alicyclic unsaturated linkage. So, at the modification, the third point is modification at the of the nitrogen substituents. So, the modification at the 3 and 6 hydroxy atom, that we can substitute with 3 OH, we can substitute with 3 OCH3, that it will yield the codeine, and the activity of codeine is the activity of this one is reduces activity to 15% of the morphine. That's next one is heterocodine, where the sixth position, that this is 6 hydroxyl group and the 6 OCH3 group. Next is modification at the 3 and 6 hydroxyl group. Sorry, same thing, 6 OH, here we have 6 OH and the 7-8 double bond. So, the oxidation of the 6 OH to a ketone, so it will give the morphinone, and the 7-8 double bonds also reduce, that is the activity of this morphinone is 37% of the morphine. Okay. Now, the removal of 6 OH, that is 6 desoxymorphine, and the 6 desoxymorphine have more active than morphine. Next is acetylation of both 3 OH and 6 OH, it will give 6 acetyl and 3 acetyl and the 6 acetyl, that is OCOCH3 and also OCOCH3. Now, this is the diacetyl morphine, and the name of this one is heroin, and it is 2 to 3 times more potent than morphine. Most of this increases due to increase of the lipid solubility, and why the activity increases? Because the lipid solubility also increases. So, here the modification of this 6-7 double bond, modification of this 7-8 double bond. So, 7-8 double bonds, that it when the reduction occurs of the 7-8 double bond, it results in slight increase in the activity, that is hydromorphine and dihydrocodeine. Next is modification of the nitrogen substituent. So, here we can do the modification at this tertiary nitrogen. So, here the tertiary nitrogen, if we are substituted this with methyl, so it shows optimum activity, 75% addiction liability is lowered. Again, if the modification at here, this is tertiary nitrogen by phenethyl substituents in place of methyl. So, activity 14 folds increases than the morphine. Okay. And the next is quaternary ammonium derivatives, that is NN dimethyl morphine have no analgesic activity, but it shows a curator like activity. Next is epoxide bridge. Here there is a one epoxide bridge in between 4 and 5. So, this epoxy bridge, that is the removal of the 3,4 epoxide bridge in the morphine structures, results in the compound that it refers to morphine. I will discuss later this morphine in detail. So, in this class morphine, the levorphenol have is more potent analgesic than morphine. There are some groups which are if we are doing the modification by in the phenolic hydroxyl group by hydrogen by COCH3, OCH3, OC2H5 and this heterocyclic ring, it produces the less analgesic effects. Alcoholic hydroxyl group means 6 OH, the phenolic hydroxyl group, that is the third OH. So, if 6 OH is replaced by OCH3, OC2H5, OCOCH3 ketonic group and the hydrogen, they are producing more active compound than the morphine. So, and there is a one linkage, the one double bond present in between 7 and 8 position. So, in this if this CH double bond CH means the unsaturation between 7 and 8 position, and if there is unsaturation that replaced with CH2 CH2, it is more active than the morphine. The fourth point is tertiary nitrogen atom. The tertiary nitrogen atom is present in the basic structure. If this tertiary nitrogen atom most optimum activity when it is substituted with CH3, if it is substituted with NH, CH3 to NCH2 CH2 PH means phenethyl ring and N allyl or propyl, it produces the if it is substituted with H, then it is a less active compound and it produces with some phenyl and aryl or propyl. So, it will produce some more active compound than the morphine, and sometimes it produce morphine antagonist. So, these are the some references. Thank you so much.